Now, given f of x equal to x cubed, find the following and the instantaneous rate of change of f when a is equal to 5. So when a is equal to 5, f of 5 is equal to 5 cubed. You just replace x by 5. So 5 cubed is equal to 125. Find f of a plus h, where a is equal to 5. So f of 5 plus h is equal to 5 plus h cubed. Then you expand this using the formula, if you recall. If you have a plus b cubed, this is equal to a cubed, you cube the first term, plus 3 times the square of the first term, a squared, times b. So it's 3a squared b plus 3 times a b squared, and then plus b cubed. So following that pattern, we have cube of the first term, cube of 5 is 125, plus 3 times the square of 5, which is 25. 3 times 25 is 75. So 75h plus 3 times 5. Our a is 5. So 3 times 5 is 15. And then h squared. Lastly, you cube the last term, cube h. So you have h cubed. Then find this difference quotient here. Letter B, you want to find f of 5 plus h minus f of 5, because a is equal to 5, divided by h. So this is equal now to 125 plus 75h plus 15h squared plus h cubed minus our f of 5 is equal to 125 divided by h. Now 125 here will cancel with the 125 here. Then you are left with an expression where h is a common factor. So we can go ahead and factor out h. We have h times 75 plus 15h plus h squared. Then divide this by h. Then h will cancel out. And then letter C, to find the instantaneous rate of change of f when a is equal to 5, that is just equal to the limit of f of 5 plus h minus f of 5 divided by h as h approaches 0. Now, this expression here is equal to this. So therefore, we have limit of 75 plus 15h plus h squared as h approaches 0. And evaluating the limit here, we have, as h approaches 0, we have 75, because this goes to 0, this one goes to 0, therefore we have 75. So the instantaneous rate of change of f when a is equal to 5 is 75. Next question. A company determines that the cost in hundreds of dollars of manufacturing X cases of USB drives is given by this equation here, where X is between 0 and 20. Find the instantaneous rate of change with respect to the number of cases produced when 5 cases are produced. The instantaneous rate of change can be computed by finding the limit of C of 5 plus H minus C of 5 all over H as H approaches 0. So the cost or the C function is given by this expression here. So let's go ahead and find first C of 5 plus H. So C of 5 plus H is equal to negative 0.2, and then you replace X here by 5 plus H plus 8, and again replace X by 5 plus H plus 40. Then expand 5 plus H squared. So expanding 5 plus H squared. So copy negative 0.2. 5 squared is 25 plus 10H plus H squared. Then you distribute 8 to each term in the parentheses. So plus 40 plus 8H plus 40. Then distributing negative 0.2 to each term inside the parentheses here, we get negative 5 minus 2H minus 0.2H squared plus, then you write this 8H, and then 40 plus 40 is 80. Then you combine similar terms. We have negative 0.2H squared, negative 2H plus 8H is 6H, and 80 minus 5 is 75. Then we compute for C of 5. C of 5 is equal to negative 0.2 5 squared plus 8 times 5 plus 40. So negative 0.2 times 25 is negative 5. 5 times 8 is 40 plus 40. So this gives us 75. Now let's go ahead and plug this into our equation here. So therefore we have the limit of C of 5 plus H is this expression here. So negative 0.2H squared plus 6H plus 75. Minus C of 5 is 75. So minus 75 divided by H. H approaches 0. So 75 minus 75 is 0. And then H is a common factor here. So you can divide each term by H. This will then be reduced to negative 0.2H plus 6. And then you take the limit as H approaches 0. So as H approaches 0, this term here becomes 0. So this gives us 6. Now, based in the context of this problem here, we say that when 5 cases, so that is when X is equal to 5, so when 5 cases are manufactured, the cost is increasing at the rate of 6, but the 6 here is in hundreds of dollars. So that means at the rate of $600 per case.